Section 2.4 is the product and quotient rules. So the product rule, obviously product means multiplication, quotient here means division or fractions. So how do you find the derivative when you multiply two functions, and how do you find the derivative when you divide two functions, have the quotient of two functions? And this is the first time where we're going to break from the limit rules. With the limit rules, remember, a derivative is just a limit, right? It's the limit as h approaches 0 of f of x plus h minus f of x all over h. However, we do have the limit of the product is the product of the limits. And the limit of the quotient is the quotient of the limits. Those were two of our limit rules, as long as the denominator wasn't 0. But those are not at all the rules when it comes to derivatives. These are proved in the back of your book in the auxiliary section, but you don't need to know the proofs of these. I'm just going to teach you the rules, and I need you to memorize the rules. So let's take a look at this together. It says the product rule. It says the derivative of the product of two differentiable functions is equal to the first function times the derivative of the second plus the second function times the derivative of the first. So here they're calling f of x the first function and g of x the second function. So they're doing f of x times g prime of x. So that'd be the first times the derivative of the second plus g of x, which is the second, f prime of x, which is the derivative of the first. So this would be the second times the derivative of the first. So again, that's first times the derivative of the second plus the second times the derivative of the first. That's what I have written right there. It says the derivative of the product is the first times the derivative of the second plus the second times the derivative of the first. But that takes forever to say. So my students over the years have come down to this. They really like this version of it. If they call the first function 1, and they call the derivative of it d1 for the derivative of the second function 2, and then you have d2, then the product rule comes a lot easier. The derivative of the first times the second is 1d2 plus 2d1. So that'd be 1 times first times the derivative of the second plus the second times the derivative of the first. But it's a lot easier to remember 1d2 plus 2d1. So this is the one that my students traditionally prefer to memorize. Totally up to you how you want to memorize it, but you absolutely do need to memorize this rule right here. Okay? So how do you find derivatives using the product rule? Well, the first thing you need to do is identify the first function and its derivative, identify the second function and its derivative, and then you just plug it in. So we're just going to find the derivative of each piece and then plug it into the formula. So the calculus here really isn't bad. The only calculus rule that you're memorizing new is 1d2 plus 2d1. Not too bad on that one. So let's take a look at this function right here. It says find the derivative of the following function. I'm not going to lie to you. If I saw this function on a test, if it did not straight, which this one does, this one says using the product rule. So it actually wants you to use the product rule. If it says using the product rule, you have to use the product rule. But what stinks about this section is we're too early on in our derivative rules to do any problem that truly would require the product rule. For instance, on this problem right here, if this were on the test and it didn't say using the product rule, I'd just multiply it out. I'd FOIL it out. So I'd do 4x times 6 would be 24x. Give me a second. Let me grab my pen. So that'd be 24x. And then I'd have 4x times minus 3x. Well, isn't that minus 12x squared? 3x squared times 6 would be plus 18x squared. And then 3x squared times a negative 3x, that would be what? A negative 9x cubed, if I did my math right. So if I wanted to write this in descending order, it would be negative 9x cubed. Let me clean that up. Negative 9x cubed. Then I have a minus 12x squared, a plus 18x squared, so that would be a plus 6x squared. And then I'd have a plus of 24x. Well, now if I wanted to find the derivative of that, I'm using the sum and difference rule, the constant multiple rule. I'm using the power rule primarily, right? So this would be negative 9 times the derivative of x cubed, which is 3x squared, plus 6 times the derivative of x squared, which is 2x, plus 24 times the derivative of x, which is just 1. So I'd end up with the derivative is negative 27x squared plus 12x plus 24. That is what I would do if this were a real problem. If you don't have to use the product rule, I wouldn't use the product rule. Well, what you're going to notice is every single problem on this entire section, when it says use the product rule, you could use this technique. You could just FOIL it out and not use the product rule in the real world. but because it specifically asks for the product rule, we need to use the product rule. So I'm going to kind of put this in my memory bank here. I want to remember this final answer that I got, the negative 27x squared plus 12x plus 24. We should get that same exact answer doing it the other way, which would be using the product rule. So let me go ahead and erase all that hard work that we just did of foiling it out, combining like terms, and then finding the derivative. Let's go ahead and use the product rule and see what that is. So let's take a look. Here's what the product rule is. If you realize I have one function and I have a second function and I'm multiplying them together. So it says the first thing I need to do is look at the first function and then find the derivative of the first function. Well, this isn't too bad. The first function is 4x plus 3x squared. Well, what's the derivative of that? Well, the derivative of 4x would be 4 times 1, which is 1. And the derivative of 3x squared would be 3 times 2x, which would be 6x. No, I don't need to see those intermediate steps anymore, because that's not all you're doing in the problem. Let's look at the second function. The second function was 6 minus 3x in the original problem. So what's the derivative of the second function? Well, the derivative of 6 is 0. And the derivative of negative 3x would be negative 3 times 1, which is simply negative 3. So what's the beauty of the product rule? The product rule allows us to go the first times the derivative of the second plus the second times the derivative of the first. That's what the product rule is. First times the derivative of the second, so y prime would equal 1 d2 plus 2 d1. So let's just plug those in. The first was 4x plus 3x squared. The derivative of the second is negative 3. The second function is 6 minus 3x, and the derivative of the first function was 4 plus 6x. So what do we do now? Let's just distribute it out, combine like terms. Negative 3 times 4x would be negative 12x. Negative 3 times 3x squared would be minus 9x squared. We have to do some foiling out here. 6 times 4 would be 24. The outer 6 times 6x would be plus 36x. The inner would be minus 3x times 4, which would be minus 12x. The outers would be minus 3x times times a positive 6x, which would be minus 18x squared. Let's write it in descending order and combine like terms. I see a negative 9x squared and a minus 18x squared, which was negative 27x squared. Those are gone. I see a minus 12x, and a plus 36x. That should give us our plus 12x. And then the last term we have left is a plus 24. And there it is. That's our derivative function. Now go ahead and look at what we got when we expanded it out. When we expanded it out, that's the exact same answer we got. Negative 27x squared plus 12x plus 24. I do want to emphasize again, you guys are going to be taking a test. And on this test, if the problem states, you have to show your work on tests. On tests, you are submitting your work. And if the problem says find the derivative using the product rule, and you expanded it out like I did the first time, even though you got the correct answer, I cannot give you credit. If it says use the product rule, you have to use the product rule. Again, the product rule is 1d2 plus 2d1. And I also want to let you know that while the product rule is not necessary in this problem, it is because it asks for it, but if you just had to find the derivative, you could do what you want. There are problems where the product rule absolutely is 100% necessary, so you would have to use the product rule or you couldn't get the answer.